Welcome to PostgreSQL AI Monitor Pro, a production-grade commercial monitoring platform built specifically for PostgreSQL. It combines real-time metrics collection, an artificial intelligence recommendation engine, predictive alerting, and enterprise security, all wrapped in a modern glassmorphism interface. In this walkthrough, we will cover the supported operating systems, the supported deployment platforms including Amazon Web Services, Microsoft Azure, Google Cloud, on-premises data centers, Docker, and Kubernetes, and then we will tour every functional section of the application end-to-end, explaining the features, the benefits, and real-world use cases. Under the hood, the backend is built with Python 3.12 and Fast API, using SQL Alchemy 2.0 in fully asynchronous mode with the scikobk3 driver. Background work such as metric collection, AI analysis, alert evaluation, and report generation runs on Celery workers backed by Redis, with a dedicated queue for each task type. The front end is a Next.js 14 application, using the app router, written in TypeScript, styled with Tailwind CSS, and charted with rich charts, using React Query for data fetching and Zustend for global state. Real-time updates are pushed over WebSockets. The AI engine supports OpenAI, Anthropic Claude, a locally hosted Llama model, Azure OpenAI, or a fully offline rule-based fallback, so the platform works even without any external API key. PostgreSQL AI Monitor Pro supports every actively maintained PostgreSQL major version, from version 14 through version 18. A dedicated compatibility layer detects the server version at connection time and automatically selects the correct system catalog queries. So the same monitoring dashboard works identically whether you are running an older long-term support release or the very latest PostgreSQL version. The platform installs cleanly on every major operating system. On Linux, one-command installer scripts support Ubuntu, Debian, and RHEL-based distributions including Rocky Linux and Alma Linux. On macOS, a dedicated install script handles homebrew dependencies and Docker desktop integration. And on Windows, a PowerShell installer script automates the setup using Docker Desktop with WSL2. Every operating system ultimately runs the same Docker Compose stack, which means the behavior of the platform is fully consistent no matter which host operating system your operations team prefers. Deployment flexibility is a core design goal. PostgreSQL AI Monitor Pro runs on Amazon Web Services, Microsoft Azure, and Google Cloud Platform, as well as fully on-premises in your own data center with no cloud dependency at all. Containerized deployment is first class. A 10+ service Docker Compose stack for development and production, and a Kubernetes Helm chart for orchestrated, horizontally scalable deployments. On Amazon Web Services specifically, the platform includes automated discovery for RDS and Aurora PostgreSQL instances, scanning your account and importing clusters with a guided 3-step wizard. Azure Database for PostgreSQL and Google Cloud SQL targets are fully monitored as well, added through the manual add cluster flow, since automated discovery is currently AWS only. The architecture is straightforward and built for reliability. Browsers connect over WebSocket through an Nginx reverse proxy terminating TLS1.3 into the Fast API backend. Celery Beat triggers metric collection every 30 seconds. The collector connects to each target cluster and runs roughly 40 queries against PostgreSQL system views, caching results in Redis with a 5-minute time to live, while historical snapshots are persisted into a monthly partition table for long-term trend analysis. Every 5 minutes, an AI analysis task evaluates the latest metrics against 17 built-in rules and, if configured, an external language model, generating ranked recommendations that the front end polls automatically. Access begins at a secure login screen. Authentication is backed by JSON Web Tokens, with a 60-minute access token and a 30-day refresh token, and sessions are managed in Redis so they can be revoked instantly. Role-based access control governs what each user can see and do, and the platform also supports external identity providers such as LDAP, Active Directory, OAuth 2 with Google, GitHub, or Azure AD, and SAML for organizations that need centralized identity management. Once logged in, The main dashboard gives an immediate, at-a-glance view of every monitored target: health scores, connection counts, cache hit ratios, replication status, and active alerts, all rendered in the platform's signature glassmorphism style on a pure black background with neon cyan and neon green accents. This is the screen a database reliability engineer opens first thing every morning to know instantly whether anything across the fleet needs attention. The Servers section lists every standalone PostgreSQL instance you monitor, each with a live status badge, version, and key health indicators. This is the right model for single primary databases that are not part of a replication topology, such as a development database or a small application's primary instance. Adding a server takes seconds. Supply a host, port, database name, and credentials, which are immediately encrypted at rest using Fernet symmetric encryption before being stored, so raw database passwords are never persisted in plain text anywhere in the system. Each server gets its own detail view with 10 dedicated monitoring tabs: Overview, Databases, Queries, Vacuum and Bloat, Locks, Host Metrics, Capacity Planning, Backup and Recovery, Assessment, and Security, giving a single pane of glass for every operational concern a DBA needs to track. For teams running PostgreSQL in Amazon Web Services, the platform offers automated cloud discovery. Instead of manually entering connection details for every instance, you point the discovery wizard at your AWS account and let it find your databases for you, dramatically reducing onboarding time for large RDS and Aurora fleets. The first step of discovery is supplying scoped AWS credentials or an IAM role, with permissions limited to read only RDS and Aurora describe calls, following the principle of least privilege, so the monitoring platform never has write access to your cloud infrastructure. Next, the platform scans the selected AWS region and presents every RDS and Aurora PostgreSQL instance and cluster it finds, including multi-node Aurora clusters with their writer and reader topology already mapped out. Finally, you select which discovered instances to import, and the platform automatically creates fully configured monitoring targets for each one, complete with the correct node roles. What used to be a manual, error-prone, per-instance setup process becomes a guided 3-step wizard. The Clusters section is built for replicated topologies, a primary node with one or more standby replicas, whether streaming replication, logical replication, or an Aurora multi-writer cluster. Each cluster card shows the aggregate health of every node at a glance. Creating a cluster manually lets you register a primary and any number of standby nodes individually, which is exactly the flow you would use for an Azure database for PostgreSQL Flexible Server, a Google Cloud SQL instance, or any on-premises streaming replication topology where automated discovery is not available. Clicking into a cluster reveals a per-node breakdown, distinguishing the primary from each standby, so you can immediately see if one specific replica is falling behind or showing elevated resource pressure rather than guessing from an aggregate number. Selecting any individual node drills down into that node's own 11-tab monitoring view, the same depth of detail available for standalone servers, plus a dedicated replication tab, so cluster monitoring never sacrifices granularity for convenience. The Replication tab is where streaming replication health lives. Replay lag in both bytes and seconds for every standby, WAL sender and receiver state, synchronous replication configuration, and replication slot status. Catching lag trends early here is what prevents a failover from turning into a data loss incident. Beyond the headline tabs, every server and cluster node exposes deep operational detail. The Queries tab surfaces the slowest and most expensive statements straight from PG stat statements, ranked by total execution time, so you know exactly which query to tune first. The Vacuum and Bloat tab tracks dead tuple counts, table and index bloat percentage, and auto vacuum run history, flagging tables that need a manual vacuum or a tuned auto vacuum scale factor. The Locks tab shows real-time lock waits and blocking sessions, so a production incident caused by lock contention can be diagnosed and resolved in seconds instead of escalating into an outage. And the Host tab reports CPU, memory, and disk utilization for the underlying server, using the optional system stats extension when available. Capacity planning projects forward from current growth trends, database size over time, connection growth, and storage forecasts, helping you budget disk and instance sizing weeks or months ahead of actually running out of headroom, instead of reacting to a disk-full emergency. Backup and recovery gives visibility into your backup posture. When the last backup ran, WAL archiving status, and point-in-time recovery readiness, so disaster recovery preparedness is something you can verify continuously rather than discover is broken only during an actual disaster. The Assessment Center runs a comprehensive health checkup against best practice benchmarks covering configuration, performance, and maintenance, producing a prioritized punch list, which is invaluable both for new hires inheriting an unfamiliar database and for routine quarterly health reviews. Security is treated as a first-class feature, not an afterthought. Target database credentials are encrypted at rest with Fernet symmetric encryption. The web application enforces JSON Web Token authentication with role-based access control, and the bundled Nginx layer terminates TLS1, 3 with modern cipher suites, security headers, and rate limiting. A dedicated security tab per target also audits the target database itself, checking for things like overly permissive roles, unencrypted connections, and outdated extensions, giving you a security posture score for every monitored database. The AI recommendations engine is the heart of the platform's intelligence. 17 built-in rules continuously evaluate live metrics for conditions like high connection utilization, low cache hit ratio, replication lag, table bloat, unused or duplicate indexes, and deadlocks. Each recommendation includes the business impact, the technical root cause, a concrete action with copy-paste ready SQL, a stated risk level, and a rollback plan, so a DBA can act with confidence instead of guessing. When an external AI provider is configured, an optional large language model layer adds deeper, context-aware analysis on top of the rule-based foundation. And when no provider is configured, the rule-based engine still works completely offline. The Partition Advisor analyzes your largest tables and recommends whether range, list, or hash partitioning would help, based on table size, growth rate, and query patterns, then generates the exact DDL to implement the partitioning strategy, turning a complex manual schema design decision into a guided, data-driven recommendation. AI Chat lets you have a natural language conversation with an expert PostgreSQL assistant that already has your live cluster metrics as context. Ask about replication lag, query performance, or vacuum strategy in plain English, and get specific, actionable answers with exact SQL commands and stated risk levels, routed automatically to Anthropic Claude, OpenAI, a local Allama model, or the offline rule-based assistant, depending on which provider key is configured. Alerting follows a deliberately simple, reliable model. Every alert, at every severity from low to critical, is always visible on the in-app dashboard and alert history page. For critical severity alerts only, the platform additionally sends an email notification over SMTP, keeping the signal-to-noise ratio high for the channel that goes outside the application. 11 alert rules ship out of the box covering replication lag, connection saturation, cache degradation, and deadlocks, and custom rules can be authored through the REST API. The report section generates point-in-time or scheduled snapshots of cluster health as PDF, Excel, or CSV documents, ideal for weekly stakeholder updates, compliance evidence, or simply archiving a record of database health before and after a major change. Settings centralizes account management. Changing your password, reviewing configured AI providers, alert channel status, and authentication policy, including token expiry and password complexity requirements, giving administrators one place to confirm the platform's own security configuration. Getting started is fast. Run the one-line installer for your operating system, or simply execute make start to bring up the entire 10+ service Docker Compose stack. PostgreSQL, Redis, the fast API backend, Celery Workers and Beat Scheduler, Flower for task monitoring the next. JS Frontend, Nginx, Prometheus, and Grafana. For Kubernetes environments, a Helm chart deploys the same stack with horizontal scaling and rolling updates. Database schema is managed through Alembic migrations, applied with a single make migrate command, and the default administrator account is seeded automatically on first boot. That completes our tour of PostgreSQL AI Monitor Pro. Built for PostgreSQL versions 14 through 18, deployable on Linux, macOS, and Windows, running on Amazon Web Services, Microsoft Azure, Google Cloud, on-premises, Docker, or Kubernetes, and packed with deep monitoring, an intelligent recommendation engine, partition advice, a conversational AI assistant, reliable critical alerting, and enterprise-grade security. Thank you for watching, and welcome to Smarter PostgreSQL Operations.